Hey guys, and welcome to chapter 22, a new chapter, new unit, and chapter 22 is going to go over the respiratory system diseases, which is a lot. Okay, so first off, let's talk about the structure of the respiratory system. So basically, what is the point of the respiratory system? It's just basically your natural gaseous exchange, right? So oxygen for carbon dioxide, vice versa. So there's going to be exchange between the atmosphere and the blood going near the lungs basically to replenish itself of oxygen because you're breathing in oxygen into your lungs, right? So this shouldn't be new to you guys. It's divided into two main parts. We have the upper respiratory system and the lower respiratory system. And what you'll see is that our infections are going to cover first the upper respiratory part and then the lower respiratory. Okay, so what constitutes the upper respiratory system? Basically, it's you have your nose, right? So this is pretty much like the only part of the respiratory system that is like in direct contact with the outside. And you also have to think about like your skin of the nose. So it's in contact with your skin. So a lot of the skin microbiome bacteria can also be found in your nose or on your nose. You have the nasal cavity. This is going to be lined with hairs and ciliated mucous membrane. This is really important. So these hairs and the ciliated mucous membrane are going to be the ones that kind of catch different like pollutants and dust particles and microbes, right? And that the stickiness of the mucus is part of that, one of your defense mechanisms to catch those microbes. And it's amazing because through ciliary action, which we'll talk about in a bit more later on, it basically moves, this mucus gets moved to the back of your throat. So this is known, actually, I'll just talk about it. This is known as a ciliary escalator, wherever it may be. I don't know where it is. It should come up. Anyways, the ciliary escalator, which we have, like, even lining like our pharynx and like, our trachea, bronchi, so moving into the lower respiratory system. But it's just these cilia that line your respiratory tract, and the cilia move. Cilia are just little hair appendages, and they move so that they can bring up, along with the mucus, all the particles and microbes like kind of embedded and stuck within the mucus. And so with your nose, it's brought down towards the pharynx. With your upper respiratory tract, the cilia escalator is moving up. Okay, that's why it's called the ciliary escalator in your lower respiratory tract. So it moves up, so it can bring all that mucus with whatever things it has stuck in it to your pharynx, so that you can then swallow it, and basically, essentially, your stomach acid gets rid of your mucus and all the other stuff, right? Sinuses also are part of the upper respiratory system. So it's just like these kind of like hollow cavities, sinus, not hollow, but yeah, like in it you have fluid that fills the nasal cavity. The pharynx is lined with the ciliated mucous membrane, and it propels mucus and contaminants into the digestive system so that the stomach acid can get rid of them. And then, of course, you have your uvula at the back. Uvula at the back. So the upper respiratory system, it collects air, filters dust, pollen, microorganisms, and other contaminants from the air, and then it delivers the air, basically this filtered air, to the lower respiratory organs. So the ciliary action is very important. These little hair-like stuff, very important for our entire respiratory system. This is how we filter our air. The mucus of the upper respiratory system contains antimicrobial chemicals as well. Actually, that is true. We have different kind of chemicals like lysozyme or defensin, and these different things can actually go ahead and like harm our bacteria, both gram-positive, not our, but any kind of invading bad bacteria. Okay, so the structures of the lower respiratory system, we have the larynx, so your voice box, trachea, bronchi, bronchioles, and alveoli. So those three are basically your lungs. And then, of course, you have the diaphragm, which is the major respiratory muscle in your respiratory system. So there's various components of the lower respiratory system that are there for protection. We have that ciliated mucous membrane. I kind of already touched on this. This is where I'm talking about it. Okay, I kind of already touched on this, but we have like this, again, our trachea, everything is basically lined with these cilia, right, that move like the microbes, etc., up towards your pharynx. Okay, so any kind of mucus that you have will basically be a trap for whatever dust and pollutants, and then and microbes, and microbes especially. And then with the ciliary escalator, as it moves up, right, as you have that ciliary action in the movement, it's going to move the mucus all the way up to your pharynx, or from your nose, it's going to go down towards your pharynx. So basically, in essence, that ciliary action is basically to bring that mucus and whatever is embedded and stuck within that mucus towards your digestive system, right? It is actually really interesting. I've had people who ask me, like, why do we cough? Why is it that when we're sick, sometimes we cough? The reason why we cough is because when we're sick, our ciliary escalator, our action, like the cilia action, stop. And so basically it's up to you to cough up all of that mucus that you have in your lungs. And because that ciliary escalator is stopped. Well, normally it works, and it's just you have a natural progression of constant mucus and phlegm kind of going into your digestive system. While coughing, that's the reason why we do it. It's just there's so much mucus, and our ciliary escalators, a lot of times either they can't keep up, or some infections even completely annul the ciliary escalator movement. And then there's other things like smoking, for example, that kind of inhibits the action of the cilia moving. It stops the cilia from moving, but that's a whole other story. So we have the ciliary movement. We also have alveolar macrophages. So literally from the blood vessels that line like your alveoli, etc., in your lungs, like macrophages can leak into the alveoli, and they become alveolar macrophages. So these macrophages will literally phagocytize the bad guys, the bad germs. And then of course we have secretory antibodies. In fact, these secretory antibodies can even be secreted from things like tears and everything. Yeah. Okay. So in all this, I don't have it written in my slides, but I do want to also point out that everything is connected, especially when you think about things like ears, eyes, nose, everything is connected. Like even your tonsils, right? So even like your lymphatic tissues and stuff, everything is connected in these particular areas. So a lot of things are basically exposed. I want to just mention that. So the microbiome of the respiratory system, typically we have a very well-established microbiome and bacteria in our lower respiratory system, but we shouldn't at least have any bacteria below in our, wait, what did I say? Below in our lower, did I say upper before? So sorry, in the upper respiratory system, of course, that's the part that's like most exposed to the environment. So you do have a microbiome, but then below, when you go underneath, like below that, not underneath it, you go to your lower respiratory system, and that's when you typically don't have any microorganisms. Sorry, I got distracted by a hawk, like outside my window. I'm sorry. So normally there's no microorganisms in the lower respiratory system. This is because of that ciliary escalator that we talked about, and various other components that protect the lower respiratory system, like the secretory antibodies and the alveolar macrophages. In the upper respiratory tract, this is it's much more. You have lots of different kinds of microbes infecting and colonizing that particular area. A lot of them come from the skin as well. So we're going to find diphtheroids. If you remember back to the skin microbiome, we had diphtheroids. Diphtheroids can be found there. You can have all sorts of different kinds of gram-positives like Staphylococcus aureus, right, can be found in our nose. So if you have an infection, usually you put topical antibiotics in your nose as well, like a staph infection, to get rid of any kind of staph source. You can even have like different kinds of streptococci. Usually it's like alpha hemolytic streptococci, and nothing like beta hemolytic streptococci, like Streptococcus pyogenes, which is like really terrible. Usually is not found there, but something like Streptococcus pneumonia is. In fact, this is, remember, going back to, I don't know which chapter, but Streptococcus pneumonia being already part of our mouth microbiome, right, upper respiratory system microbiome. This can cause people that are immunocompromised, elderly, and therefore a little bit more immunosuppressed to develop meningitis. Streptococcus pneumonia causes meningitis in kind of like more elderly people because it's already part of their microbiome, but they already have it. And usually, and we have it as well, right? But usually as adults, we have a strong immune system and we can keep it at bay. If you're immunosuppressed in some way, you can't keep that Streptococcus pneumoniae at bay as much, so it becomes opportunistic and it can cause meningitis, so bacterial meningitis. So yeah, there could also be pathogenic microbes in our upper respiratory system. But for the most part, they're actually really important because they help with that molecular antagonism, right? Since every single spot is covered in the upper respiratory system, it basically makes it harder for another microbe to go in and infiltrate your system, since it's going to have to compete for habitat and for food. So it is, it is kind of a defensive mechanism as well. And yeah, so the normal microbiome limits the growth of pathogens. Okay, so that is it for part 1, and I shall see you guys in the next section. Bye, guys.